Alright guys, we're going to go over Firestarter 13 pretty quick. Number one is list the possible rational zeros of f of x equals 3x to the fourth plus 7x squared plus 5x minus 12. Remember, that's just step one. That's just finding the p's and q's and writing out the factors. So that's just easy stuff. Remember, p is always the last one, and q is always the first one. So I'm going to find my factors of 12. That's 1 and 12. That's 2 and 6, and 3 and 4. Remember, I always count. Like, I start with 1. 1 always works. Then I try 2. Then I try 3. The next number I would try after 3 is 4. It's already on the list, so I know I'm done. If you go in order, it's a good way to make sure we get all the factors. The factors of q are just 1 and 3. I'm going to change some colors a little bit, actually. So, I'm going to make my q's a different color. So I'm going to make my q's dark blue. Alright, so my q is 1 and 3. So what I'm going to do is I'm going to take all my p's, I'm going to write them over all my q's. And I'm going to add a plus or minus. So the first thing I'm going to do is I'm going to write plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. All right. I would put them all over 1. You could write it like this. All right, so then you actually have the p's all over the q. So I took all these p's, 1, 2, 3, 4, 6, 12, and I wrote them all over the q, 1. Right? So that's one set. Now, I will very rarely ever write this part right here, because anything over 1 is itself. Remember, you always want to have this simplified, so that's why we're doing it that way. Now, I'm going to do the same exact thing again. This time I'm going to write my p's again. And guys, a good rule of thumb is you're going to write your p's as many times as however many q's you have. So if you have 5 q's, which is not really likely, but it's possible, I guess. If you had 5 q's, 6 q's, you would write all your p's 6 different times, and then put a different denominator every time. So now I'm going to write my p's again, plus or minus. And remember, you need the plus or minus because that sign could be either or. And remember, these are just options. These are just things that could work. We're just limiting our search. Alright, and now I'm going to put them all over 3. So I have 1/3, 2/3, 3/3, 4/3. Oop, wrong number I wrote. The keyword for this video is going to be bubble guppies. The keyword for this video is bubble guppies. Alright, now the last thing I do is I do simplify my fractions. So 1/3, 1 is good, 2, plus or minus 1, plus or minus 1, plus or minus 2, 3, 4, 6, 12. Those are always going to stay. Now 1/3 can't be simplified, so it's not a repeat. 2/3 can't be simplified, so it's not a repeat. 3/3. 3/3 is the same thing as 1, so that's a repeat. I don't need that again. 4/3, okay. 6/3 is just 2, so I don't need that. And 12/3 is 4, I don't need that. So remember, you always cross off the repeats. Number two is we're going to find all the zeros. So I have not given you a factor. That means you have to do p's and q's. So I did not say given a 0 or given a factor. So that means I'm going to do p's and q's first. So there's my p. Remember, 1 is my q. Even if you don't see that 1 there, it's there. So my p's over my q's are going to be plus or minus 1, plus or minus 3. Right? So that's going to work. That's all that. Remember, I have 1 and 3, so that's why I have plus or minus. And then, since q is 1, there isn't a bunch of repeats. All right, so I did step 1. Step 2, guess p and q until there is no remainder after the division. So I'm going to make my box. Inside my box, I'm going to put 1, -3, 1, -3. Now I'm just going to guess. I'm just completely guessing. I'm going to guess 3. So if 3 works, it's a 0. 1 times 3 is 3, I get 0. 3 times 0 is 0, I get 1. 1 times 3 is 3, I get 0. It's no remainder. That means my first 0 is going to be x equals 3. Now, I can repeat the steps. So I did that one. I can repeat the steps. So I could make a new box and keep on trying. The problem with this one is there are no more good answers. So what I'm going to have to do is use the quadratic formula, or I could use some solving methods. Remember, when I do synthetic division, it makes it a smaller exponent, so this becomes x squared. There is no x in the middle, plus 1. Now, because we're finding zeros, I'm going to make it equal to 0. You could solve this using the quadratic formula. Because there's only one letter, you actually could use primitives backwards. So what I could do is subtract 1 from both sides. I get x squared equals negative 1. Now to get rid of the little 2, I have to square root both sides. I get x equals plus or minus, because that's what happens when you square root both sides. Now remember, anytime there's a negative in the radical, it turns into I, so this is actually x equals plus or minus I. So there are 3 zeros. X equals 3, x equals I, x equals negative I. Those are my zeros. All right? And I knew there was going to be 3 zeros because remember, the degree tells us the number of zeros. All right, number 3 on the Firestarter is almost the exact same thing that we just did, just a little bit bigger, I would say, because it's got 4 terms. I mean, it's got the 4th power, so I know right away that I'm going to have 4 solutions. So right away, that tells me there's going to be 4 solutions. Doesn't mean they're all going to be nice solutions. It just means there's going to be 4 total solutions. All right, so first thing I'm going to do, if you're not sure what to do, I'm following these hints right here. All right, find P and Q. So P is 48 and Q is 1. Now 48 gets kind of messy because 48's got a lot of factors. So my P's over my Q's, these are just the factors of 48. I just didn't want to write them out twice. I got plus or minus 1, plus or minus 2, plus or minus, so it's 1 and 48. It's 2 and 24. 3 and 16. So we got plus or minus 4 and 12. 5 doesn't work. 6 works, plus or minus 6. And 8. And then 7 doesn't work, and then 8 would be the next one. It's already on the list. So right now, I'm going to make my box. So I did step 1. Step 1 done. Now I'm going to step 2. I'm going to guess any of my P's and Q's. I don't have to make any fractions because Q is 1. If Q was a bigger number than 1, I'd have all these plus fractions. Right? But I don't have any fractions. So I'm going to make my box. Remember, inside my box, I'm going to put 1, negative 7. Let's make that legible. 8, 28, negative 48. Now I'm just going to guess. I'm going to guess what I think is going to work. It depends on if I'm not sure what's going to work. I just start with 1, and then I try the negative 1. So I could do that. I could try 1. 1 times 1 is 1. I get negative 6. 1 times negative 6 is negative 6. I get 2. 1 times 2 is 2. I get 30. 1 times 30 is 30. This gives me negative 18. Since that's a remainder, I know 1 doesn't work. Now, a lot of times, what I do is I always try the negative immediately after. So I don't, if that didn't work, I try negative 1. So let's make that negative 1. Then I get 1 times negative 1 is now negative 1, so this becomes negative 8. 1 times negative 8 is positive 8. So this becomes 16. Negative 1 times 16 is negative 16. So this becomes 12. And then negative 1 times 12, negative 12. It's going to have a remainder. So now I know 1 is never going to work. I never have to check 1 or negative 1 again the rest of this problem. So now I'm going to go all through it again. All right, this time I'm going to check 2. So I say 1, negative 7, 8, 28, and negative 48. Once again, if it depends. If I have a good feeling about a number, sometimes I'll go out of the norm and I will just, and I'll guess that number right away. But other times, I'll just do it very methodically. I will just start with 1, try negative 1, then 2, then negative 2, and so forth and so forth. So 1 times 2 is 2. Negative 7 plus 5 is going to be negative 5. Now I multiply. 2 times negative 5 is negative 10. So then I multiply. I add 8 times negative 10 is negative 2. 2 times negative 2 is negative 4. And with 24, 2 times 24 is positive 48. So look, it works. So that's my first answer. Now, it is possible that 2 could repeat. So I cannot cross off 2 from my list. So I have my solutions, or my zeros. My first one is x equals 2. Now, I'm going to make a new box. See how I'm using the new numbers, 1, negative 5, negative 2, 24. If you don't do that, you're going to run into issues. All right. So look, I'm going to try 2 again just because it's possible 2 could work twice. Remember we talked about that. It's not likely, but it is possible. 1 times 2 is 2. Negative 5 plus 2 is negative 3. 2 times negative 3 is negative 6. Negative 2 times negative 2 plus negative 6 is negative 8. And I get negative 16. It does not work. So now I can cross off 2. Now I'm going to try negative 2. Negative 2 times 1 is negative 2. I end up with negative 7 when I add. Negative 2 times negative 7 is positive 14. 14 plus negative 2 is going to be 12. Negative 2 times 12, negative 24. So it did work with x equals negative 2. So now I also have another 0, x equals negative 2. Now, I have this right here. I could say this is A, this is B, and this is C. I'm going to use the quadratic formula. You could use that, right? Or you could factor and solve. I always try to factor first, so I'm going to rewrite this as x squared minus 7x plus 12 equals 0. Like I said, if you don't want to do that, you could say this is A, B, and C, use the quadratic formula. But I know that 3 times 4 is 12, so this could be written as x minus 3, x minus 4, because 3 times 4 is 12. They also add up to the middle. They're both negative. So my answers are going to be, set them both equal to 0. My answers are going to be x equals 3, x equals 4. So I have 4 total solutions, which means I know I'm done with the problem. And that's it.